Alright, how we doing tonight? We're going to look at section 9.7. We're going to wrap section 9.7 up from our discussion in class. I don't have a whole lot more to tell you, just maybe a little bit of a refresher of what we did in class, and then one other kind of problem that we didn't have time to get to that I think might give you a little bit of trouble, so I think it's important for us to go through it tonight. But real quick, just a refresher. Here are your three inverse functions that we talked about in class today. The inverse of sine, the inverse of cosine, and then the inverse of tangent. You have to bear with me a little bit in this video. My whiteboard wasn't working too great when I did this video. Really important that you understand why our domain and range are what they are. Remember, these functions would fail the vertical line test if we continue to graph them this way. Remember that in order for it to be a function, it can only pass through in one spot. If we continue to extend those radian measures up and down, it would continue to repeat itself. And so that's why it's real important to understand the domain and the range of these functions. I'm sure we talked about it in class, but feel free to ask me again, even tomorrow or the next day or whenever, if it's just confusing for you. We'll refer back a little bit to this in the work that we do. By all means, though, push pause, look at it, think about it if you need to. Alright, so in class today, we did a relatively easy example of just finding the inverse functions of various values. You know, we did like the inverse cosine of radical of 3 over 2. Alright, and we figured out which angle had that cosine measure. Now what we're going to do is we're going to extend it a little bit, almost like it's a composite function now. Alright, so think about this as a composite function. We're taking the tangent of the inverse cosine of 2/3. Now think about what that means. The inverse cosine of 2/3. What's that mean? Translate that. That is, what angle has a cosine of 2/3? Alright, so we'll look at that part first. Then, once we find that angle, or once we have an understanding of what goes into making that angle, then we'll take the tangent of that. Alright, so step one is just going to be to kind of rewrite this a little bit, to simplify it. We're going to let u equal the arc cosine or the inverse cosine of 2/3. Alright, so if I do a little reworking, some algebra here, take the cosine of both sides, the cosine of u is going to equal, now the cosine and the inverse cosine will cancel each other out, so the cosine of u equals 2/3. Now, here's the part that I think is real important. Draw a triangle that represents that. Draw a triangle that shows angle u having a cosine of 2/3. So think about what that means. Think about what goes into making cosine. Remember, cosine is defined as the adjacent side divided by the hypotenuse. So if I draw a right triangle, and remember, since this cosine is positive, that right triangle is going to be up in that first quadrant. Again, if this is confusing, stop for a second, go back to the previous page where we had the inverse functions, or just look at your notes and look at the inverse functions. And remember, if cosine is positive, we're going to be looking at that up in the first quadrant right now. So I draw that triangle, that reference triangle, if you will, up in the first quadrant, and we're going to call that angle is u now, not theta, but angle u. Now remember, adjacent side is 2, hypotenuse is 3. Now, let's go ahead and find our missing sides. We're going to need that when we take tangent later on. So of course we'll use Pythagorean theorem with that. We'll do 2 squared plus something squared equals 3 squared. Now let my let my work catch up a little bit here. So again, we're going to use Pythagorean theorem to find that opposite side right now. So do your work there, let it all work out correctly. When you're done, b squared is going to be equal to 5, or b is equal to the square root of 5. Again, we're up in that first quadrant, so that's going to be a positive square root of 5. Now that you have that, now finding the tangent of u is really easy. And the nice part about it is it's the exact answer. It's an exact answer for the tangent of u. And so opposite is radical 5. Adjacent is still 2. And so we put all this together right now, and the answer to our problem, the tangent of the inverse cosine of 2/3 is the square root of 5 over 2. Okay, what's that mean? Just simply means it's the angle whose cosine is 2/3 has a tangent of the square root of 5 over 2. Alright, you try this one now. Once you see the problem, I'd like you to push pause for a second, work it out, follow what we did in the previous problem, and then I'll go through it and see if it made sense to you, or see if you did it correctly. Alright, hopefully you've tried it. Let's see if what I'm doing matches up to what you did. Remember, we're going to let you represent the innermost function here, the g of x, if you will. If u equals the inverse sine of negative 3/5, if I take the sine of each side, the sine of u equals negative 3/5. I'm going to draw that now. Now you notice I'm putting it down in the fourth quadrant. Remember from our discussion in class today, sine is defined from negative pi over 2 to pi over 2. So down there I've got a triangle that has negative 3 for its opposite side, 5 for the hypotenuse. In order for me now to find the cosine of angle u, I'm going to have to find the adjacent side. Again, I apologize for my technical difficulties here on my whiteboard. Just bear with me here for a second. As that's doing that, I am going to use Pythagorean theorem right here. Make sure when you do this that when you square the negative 3, you obviously get a positive 9. That's one of those kind of foolish mistakes or careless mistakes. So negative 3 squared plus a squared equals 5 squared. You might recognize this as a 3, 4, 5 right triangle, a Pythagorean triple. A does equal 4 when you work it all out. And again, that's going to be a positive 4, because over there in that fourth quadrant, the adjacent side is still along the positive x-axis. So now to solve for the cosine now, I have 4 over 5, and so the answer to this question, the cosine of the inverse sine of a negative 3/5 is going to be 4/5, and that is the exact answer. Hope this makes sense. I hope what we're doing here doesn't confuse you too much. I know it's a little bit different. We're going to use this time. We'll use our time in tomorrow in class to practice not only these problems, but also the problems that we worked on in class today. If you want to get a head start on this, you can work on the following problems. This is the wrong page. It should be page 626, numbers 5 through 40, and 55 through 64. I would say do the odd problems, since those are in the back of the book and you can check your answers, especially if you're at home tonight and you're working on these. Tomorrow in class you can work on whatever ones you want, and you can check your answers with me or with the book as well. Again, ask questions either in class or tonight on your on our calculus Facebook group page. I'll try to do my best to answer those questions, clear up any confusion you might have. But I hope that what we did on this video makes pretty good sense. Alright? See you next time, and Good luck with your work.